All right, good morning, Chazelle, Michelangelo, and Janet. So last time we started talking about module number 9, which is the Gauss or the Gaussian quadrature rules. And we mentioned that this is another quadrature formula. So involved na naman yung summation ng mga function values times some weights. All right. So, and then nakita natin yung kaibahan niya sa Newton-Cotes formula. Yung Newton-Cotes formula, free tayong pumili ng kahit anong exabytes or free tayo na gamitin kung ano man yung exabytes na given dun sa problem. All we need to do would be to find the interpolating polynomial passing through those given points, and we will integrate the interpolating polynomial instead of the actual function itself. All right. Now, meron siyang version na composite rules. Ang ibig sabihin naman nun ay sa bawat dun sa buong integration interval, pwede tayong mag-consider ng mas maliliit na intervals kung saan ipa-perform natin yung simple quadrature rules para makakuha ng better approximation without subjecting the problem to the Runge phenomenon. Okay? So in contrast to the Gaussian quadrature rules, nakita natin last time na pumipili tayo ng optimal exabytes and optimal weights associated with them based on or with respect to the degree of precision. So we said that the degree of precision of a quadrature rule is the degree of or the greatest degree for which the greatest integer for which the quadrature rule will give us the exact integral for all polynomials of degree m or less, but will fail for some polynomial of degree m plus 1. Okay? Tapos sabi natin last time, dun sa Gaussian quadrature rules, kung gagamit ka ng n points, alright? So that means you will have two n unknowns, namely the n abscissas and the n weights associated with them. Tapos yung degree of precision na makukuha natin ay 2n minus 1. Okay, degree of precision. And this method will require us to solve a 2n by 2n system. So meron tayong 2n unknowns at if we will write down the condition for achieving a degree of precision 2n minus 1. Kasi para maging degree of precision 2n minus 1, dapat eksakto yung integral na ibibigay niya para kay f equals 1, f of x equals x, f of x equals x squared, f of x equals x cubed, hanggang x to the power 2n minus 1. So there would be a total of 2n equations that we need to build up, all right? Kasi isang equation para sa isang polynomial of degree 2n minus 1 or less. So nagkakaroon tayo ng isang malaking nonlinear system. So we have a 2n by 2n nonlinear system. And as I've mentioned, unfortunately, magre-rely tayo sa numerical solvers, or actually magre-rely tayo sa symbolic solvers implemented using computers to find those 2n unknowns. All right? So pinakita ko last time yung paano siya gagawin kay MATLAB. But you can also use Mathematica, which is more apt for symbolic calculations, or you can use other online solvers. Now, ano pa ba? Yeah, meron mga numerical techniques on how to solve a system of nonlinear equation. However, sa Math 175 pa siya mako-cover. So for now, we will be content on using or relying on these solvers para ma-derive yung mga Gaussian quadrature rules. Okay? And then, para mapasimple yung derivation, yung integration interval AB, shinrink muna natin o ni-normalize natin into the interval -1 to 1. Tapos yung method na dinevelop natin to derive the two-point Gaussian quadrature rule ay nawala yung sentence ko. Pero yung ginamit nating method doon ay ni-restrict natin sa interval -1 to 1 para mas simple yung integral ng mga x to the power n from -1 to 1, resulting into a much simpler nonlinear system. Okay? And then dahil yung mga abscissas na mako-compute natin mula dun sa normalized system of equations ay mga numbers from -1 to 1, in order for us to use those formulas or the resulting Gaussian Legendre the Gaussian quadrature rule, dapat ay gamitin natin yung substitution rule pabalik dun sa interval AB. Okay? So, dun natapos yung discussion natin last time ng example 9.2. So, yun yung nangyari. Now, this method would be very cumbersome, especially for large values of n. Kasi, of course, yung solution by hand, mahirap na. Pag pinakompute natin siya sa MATLAB or sa kahit anong computers, the larger the system, the longer it will take for us to get a solution. And sometimes the solvers will just fail due to the complexity of the system. But thankfully, I found this reference, this book by Abramovich and Stigan, which is actually a handbook for mathematical functions that are used in modeling natural phenomena. Okay, na binigay niya na kung ano yung mga roots ng ano yung mga solution ng nonlinear system na kailangan natin sa Gaussian quadrature rule. And incidentally, the solutions of the 2n by 2n system that we are solving for the Gaussian quadrature abscissas are actually the roots of the Legendre polynomial. Okay? So kung meron tayong kung kailangan ko ng 2 points or kung kailangan ko ng n points para dun sa quadrature rule, ang sabi ni Abramovich, madali lang yan. Kunin mo lang yung roots ng degree n Legendre polynomial. And they will serve as the optimal abscissas with respect to the degree of precision. Okay? Tapos, ang kagandahan pa nun, binigay din ni Abramovich kung ano yung mga weights para sa bawat isang abscissa. So kung yung mga exabytes na dapat natin gamitin ay yung roots ng Legendre polynomial of degree n, yung associated weights naman can be computed using this simple formula. Okay? 2 over 1 minus exabyte squared times the derivative of the Legendre polynomial of degree n evaluated at exabyte. Okay? So, tingnan nga natin. Balikan natin yung Legendre polynomial natin. So, ang unang Legendre polynomial ay p sub 0 at ito lamang ay yung constant na 1. Of course, it doesn't make sense to talk about this kasi ibig sabihin dito degree 0. So, ibig sabihin wala siyang root. So, wala tayong point na gagamitan kay Gaussian quadrature. Okay? So, pero kung gusto mo ng quadrature rule or ng Gaussian quadrature rule using 1 point, pwede pala nating tingnan, instead of solving the system we have seen last time, yung first, yung degree 1 Legendre polynomial, which is actually just x. Tapos ang root ng first Legendre polynomial na to ay 0, making x sub 1 equal kay 0. Okay? Tapos ano yung associated weight? Yung associated weight for this guy would be 2 over 1 minus 0 squared times the derivative of p evaluated at exabyte, but p1 is just x, its derivative is 1, so this guy will be 1, so this will just be 2. Okay? And that's what it is. All right? So kaya lang dito dahil alam natin yung Legendre polynomial ay defined on the interval -1 to 1. So of course, the roots would be from -1 to 1. So kung gusto mong gamitin itong Gaussian quadrature derived using or via the Legendre polynomials, kailangan mong bumalik dun sa translation ng interval from -1 to 1 to AB. Okay? So hindi pala masyadong obvious kasi ang ginamit ko last time na derivation para sa 1-point Gaussian quadrature rule ay ginamit ko yung definition ng degree of precision tapos ang interval ay arbitrary na AB. So siguro mas familiar if we look at the 2-point Gaussian quadrature rule na dinerive natin last time. So balikan nga natin siya. Okay? So ito yung nakuha nating quadrature rule. The exabytes are plus or minus root of 1/3. Tapos ang weights associated them ay 1 and 1. So dahil 2 points yung gusto mong computein, pwede nating gamitin yung result ni Abramovich. Sabi niya, okay, kung gusto mo ng 2 points that will maximize the degree of precision, kunin mo yung roots ng degree 2 Legendre polynomial. But if you remember, the Legendre polynomials are defined recursively using this. Okay? So kukunin ko si P2 si P2 of x ay magiging, okay, n equals 2, so I'll have 3 halves x times the previous Legendre polynomial, but the previous Legendre polynomial is x, minus 2 minus 1 over 2, so that's 1 half, times the Legendre polynomial 2 steps back, and that would be the constant polynomial 1. So the second Legendre polynomial is actually 3 halves x squared minus 1 half. And if I equate this to 0 to get the roots, we'll get x equals x squared equals x equals 1/3. Tama ba? So, kung multiply ko both sides by 2, lipat si 1, divide both sides by 3. And true enough, here, we see that the roots are x equals plus or minus root of 1/3, which coincided indeed with the abscissas we computed using the degree of precision definition of the Legendre abscissas. Okay? Oh, sorry, the Gaussian the Gaussian abscissas. Okay? Tapos, yung W sub i's, mako-compute daw natin as 2 over 1 minus x sub I squared times the derivative of the degree 2 Legendre polynomial evaluated at the x sub i's. Okay. Now, plugging in the values of x sub i's here, we'll get 2 over 1 minus x sub I, actually yung square pala nito ay nasa loob dapat. Okay. X sub I squared, but our x sub i's are just these two guys. Pag in-square natin sila, makukuha natin ay positive 1/3. And then ang second derivative ng P2 ay, eto, nasan si P2? Eto si P2. So the second derivative niya ay 3x, right? And then 3x evaluated at, actually may square pa pala to. Double check ko lang yung formula. I hate memorization, kaya makikita nyo na, yeah, kailangan ko lagi ng notes kasi hindi ako magaling sa ulo ng formulas. Mas okay sa akin na i-derive sila kaysa sa uluhin. Okay? So that's the formula for the W sub i's. Gamitin ko siya dito. Kaya lang alam ko na ang derivative ay 3x. So P2 prime of x squared would be 9x squared. So I'll need to plug in the x sub i's there. Kaya lang naka-square na naman siya. So magiging 1/3 lang yon times 9 times 1/3. But this guy simplifies to 3. This guy is 2/3. 2/3 times 3 is 2. 2 divided by 2, that's 1. So indeed, ang weight associated dun sa dalawang roots or dun sa dalawang abscissas na na-compute natin ay parehas 1. As what we have gotten from the derivation we had last time. So now, kung gusto nyo ng degree 3, ng 3-point Gaussian quadrature rule, pwede nyo gamitin either yung definition natin from last time or pwede nyo tingnan ano si P3. Ano yung Legendre polynomial of degree 3. I-solve nyo yung roots niya. Okay? And I think we already did that, so I hope you guys have still have your code for computing the roots of the Legendre polynomials. May ginawa akong MATLAB script for that in one of our lecture sessions. Okay? Tapos ginamit nyo rin ito para sa problem set. So I hope you still have those codes. Kasi pwede mong kunin yung part na yun ng code, tapos para mo-compute ano yung roots ng Legendre polynomial na yon, tapos yun yung abscissas na gagamitin nyo. So you have two approaches, but either way, you're gonna get the abscissa 0 and plus minus root of 3/5. Tapos para ma-solve yung weights, so kung ginamit niyo yung method 1 na ginawa natin last time, sabay niyong makukuha yung x sub i's at saka yung associated weights. Pero kung gagamitin niyo yung Legendre approach, uunahin niyo ma-compute yung mga x sub i's, tapos pag na-compute niyo yung x sub i's, i-plug in niyo lang siya para makuha yung w sub i's. And what you'll get are these two weights over here. So just a quick note on this table. So pag 3-point Gaussian quadrature rule, tatlo yung abscissas or tatlo yung points na gagamitin, they would be 0 plus or minus 3/5. So yung weight para sa function value ni 0 ay 8/9. Tapos ang weight para dun sa function values ni root of 3/5 ay 5/9. So to build the quadrature rule, yung 3-point Gaussian quadrature rule, equal lang siya dito. So ito yung I3 of f ay equal lamang kay 8/9 times f of 0 plus 5/9 f of root of 3/5 plus 5/9 f of negative 3/5. That is, if you are approximating an integral, ito ko na lang pala siya ilagay sa taas, if you're approximating an integral from -1 to 1. All right? And the same thing should be done for the more complex Gaussian quadrature rules. So ito, pag 4 points naman yung gusto mong gamitin, kung 4 points yan, so siya ay magiging degree of precision, what? 2 times 4, so 8 minus 1, so 7. So this is a degree of precision 7 formula. Ito yung dalawang apat na exabytes na gagamitin nyo. Pa-komplikado na siya ng pa-komplikado. Tapos ito yung weights associated with this abscissas. Okay? Is that clear? Actually, maiksi lang ito. Ito na yung theoretical discussion for today. All right. So what I'll just show next would be an application of the, I think this would be the, which point? The 5-point Gaussian quadrature rule. Pero the nice connection between the Gaussian quadrature rule and Legendre polynomials prompted the renaming of these quadrature rules. Kaya more often, tinatawag yung Gaussian quadrature rules to be the Gauss-Legendre quadrature rules. So parehas lang siya. Okay. So yeah. So from now, maybe I will refer to this more properly as the Gauss-Legendre quadrature rules instead of simply the Gaussian quadrature rules. Okay. So any questions, guys, before we go to a specific example? Okay. So if there are none, so let's see this example. Let me just erase these things para mas malinis yung notes. Okay. Now, third time's the charm for ln2. So tingnan natin, i-approximate natin si ln2, but this time using a 5-point Gauss-Legendre quadrature formula. So again, we observe that ln2 is just equal to the integral from 1 to 2 of 1 over c dc. Nagpalit lang ako ng variable for some reason. I don't remember why. So, pero siya rin yung 1 over x dx natin last time. Okay. Pero yung gagamit ako ng 5-point Gauss-Legendre quadrature formula. Now, take note that the interval of integration here is from 1 to 2. But if we will refer to table 9.1, para hindi na natin siya i-derive ulit. So 5-point Gauss-Legendre. So ito na siya. Ito na yung 5 points na gagamitin. X1, X2 and X3, X3 and X4, W1, W2 and W3, W4 and W5. Okay? Kung ito yung abscissas na gagamitin natin, confined tayo sa interval -1 to 1. So kailangan natin gamitin yung translation formula na ginamit din natin last time. So that means this integral, okay, from 1 to 2 is equal to b minus a over 2, if you remember the formula, times the integral from -1 to 1 of f of, what was that? B minus a over 2t plus a plus b over 2, where t are the abscissas we computed on the interval -1 to 1. Okay? So kaya meron ditong 1/2, siya yung b minus a over 2 doon sa translation formula o doon sa change of variable formula that we derived last time. And then here, I plugged in yung ito. But keeping the variable x there, kaya pala nabago yung mga variable dito. Pero ang pina-plug in dapat natin ay yung ay yung roots na nakuha natin dun sa interval -1 to 1. So here, yeah, sinulat ko na naman siyang b minus a, pero ito dapat ay 1/2 na lang. Compute na natin siya, okay? And then ito yung quadrature formula. So ibig sabihin, ang ginawa ko lang dito ay, nasan ba yung mga weights? Medyo malaki yung mga weights, okay? So kinuha ko lang yung sum ng f of 0, okay? Times, sorry, hindi pala f of 0. F of, b minus a. So that's going to be 1/2 times 0 plus 2 plus 1 over 2. So ito yung unang function value na i-consider ko. Alright, ipa-plug in ko siya rito. Pero yun pala yung dahilan kung bakit nag-change of variable na ako dito, para alam ko na ito yung function kung saan ko isa-substitute yung mga exabytes na compute natin mula dun sa table 9, o nakita natin sa table 9.1. So ito na yung f of b minus a over 2x plus a over plus a plus b over 2. All right? So binago ko na yung denominator. Hindi na lang siya c. Hindi ako nagpa-plug in dun sa original function per se, pero dun ako nagpa-plug in dun sa function, but this time yung c value o yung original variable ay involving na yung translation ng mga roots na nandun sa table 9.1. Okay? And if you compute for this guy, all right, you'll see that you'll get this approximate for ln2, which is the best so far that we have gotten from all the quadrature rules that we have employed. Ang relative error niya ay 3.28 times 10 to the negative 8. If I remember it right, the relative error we got last time is about 0.12%. So that's what? About 1.2 times 10 to the minus 4 or minus 5. So we have gained some orders of accuracy over here. Okay? So I think that's it. Short lang talaga yung discussion today. So generalize lang natin yung method last time. Actually, hindi pala generalize because this is a completely separate, independent, and a new method on how to derive the Gaussian abscissas and the Gaussian weights via the Legendre polynomial. Okay? So guys, do you have questions? Sure,
Sir,
wala?
i-absorb
yes?
ko pa yung mga dating lessons, sir, bago ko mag-gets to.
Okay. Yeah. Pero ang kagandahan sa kanya ay independent siya dun sa previous discussion. So if you're still taking some time to understand or to appreciate yung derivation na ginawa natin last time, siguro mas madali to kasi pwede mo siyang isipin as gumagawa ka ng quadrature formula. Pero ngayon, ang mga exabytes mo ay pinipili mo to be the roots of the Legendre polynomial. Yun nga lang, babalikan nyo yung Legendre polynomial na dinefine natin several modules ago. Ni-recall ko na lang siya dito sa baba. Okay? So, kukunin mo yung roots nila. Tapos, yung associated weights ay eto. Given na rin ang formula. We won't prove this. I'm not sure how the proof goes, if it's easy enough for us or for our level here in Math 174. But let's just accept it as a fact, okay? Maniwala tayo kay Abramovich na sa kay Stigan na totoo yan, all right? And then they just coincided with the quadrature rule that will give us the maximum degree of precision, which we named last time to be the Gaussian quadrature rules. So ngayon, parang dalawang independent way of deriving the same thing. So kaya pinangalan na natin siya na Gaussian-Legendre or Gauss-Legendre quadrature rules. Okay? Right, but it's fine. Let that simmer. Minsan ganun talaga sa math. Sa unang basa or sa unang discussion, mahirap siyang intindihin or hindi niyo siya fully ma-understand. But give it some time. Hayaan niyo siya mag-simmer sa mga utak niyo. In-inin muna natin siya. And hopefully in time for the next lab exer, you will be prepared for this topic. Okay? So, anyone else who has any question or would like to voice out something? Kumusta naman? Oh, yes, Lian.
Sir, may question lang po dun sa last example po.
Uh-huh.
Yung dun po sa may, yung before po, ayun po sa may approximately, ano po, summation. Yan po ba, sir, yung formula po na, yung general, ano po, quadrature formula po? Kaya po
Uh,
nasabi na summation of something-something na siya.
yes, kasi remember yung Gaussian quadrature formula, ganito yung itsura niya. Lagi siyang summation ng function value times the weights. Dito 5 points yung ginamit natin, no? 1 over 5, 1 to 5, okay? Tapos ngayon, alam natin yung function ay 1 over x. So supposedly 1 over x sabay yung ipa-plug in ko, right? So yun yung laging ganito yung quadrature formula. Ang kaibahan nitong Gaussian, yung x sabays ay pinili natin specifically to be the roots of the Legendre po. Kaya lang, yung integral na ina-approach natin ay integral from 1 to 2. Yung roots ni Legendre ay integral ay nasa interval negative 1 to 1. So ibig sabihin ngayon, kailangan kong gamitin yung translation formula na natutunan natin mula dun sa change of variable natin last time, na ito pala dapat kong gawin ay weighted by b minus a over 2 times summation from 1 to 5 ng weights times function value ng b minus a over 2 times t plus a plus b over 2. Alright? Kasi ito yung translation formula. Yung roots na nakuha natin kay Legendre, dapat i-translate ko dun sa appropriate interval. Ngayon, ang interval natin ay 1 to 2. So, plug in ko yung mga information na yon, magiging 1 to 2, no? So, this would be 1 half summation from I going from 1 to 5. The weights are unchanged. Ito yung weights na nakuha natin from the Gaussian quadrature. So yung weights na gagamitin nyo ay ito, W1, W2 and W3, W3 and W4. Okay? Tapos, yung function values ngayon ay ito. So magiging plug-in natin siya, magiging 1 half t plus 3 halves. Okay? Kaya lang, yung function natin ay 1 over x. So kung 1 over x yung function, ibig sabihin ipa-plug in ko to as my value for x. It would be 1 over 1 half t plus 3 over 2, where t are the roots, or the t sabays are the roots of the Legendre polynomial of degree 5. Okay? Kaya yung itsura niya ay na-simplify na dito. Okay? Pero in general, dapat siya evaluated at the translated roots of the Legendre polynomial. Okay?
Pero
So
po,
I hope that...
sir, ay sorry po. May
Okay,
last
go ahead.
question na lang po, sir. Di ba po
Mhm.
sa weights po, sir, ay tatlong values lang po yung meron. So, paano po yun? Until 5 po yung n.
Yeah. Pero dito sa table, so kung ito si yung katapat niya, yun yung associated weight. So ito ay z0. Ang weight assigned sa kanya ay 128 over
Okay po.
25.
Gets na
Dito
po,
sa
sir.
dalawang to, naka-plus minus siya, no?
Oh,
Nagtipid kasi ako sa space at mahirap mag-type sa latex. So, na-encounter nyo na yan. So, messy talaga mag-latex. So, kaya inisa ko na lang siya na row. Pero ang ibig sabihin niya ay dalawang number, itong plus or minus 1/3 times root ng 5 minus 2, root ng 10 over 7. Pareha silang may root na 322 plus 13 root 70 over 900. Okay? So
okay po,
lima pa
sir.
rin. Tatlo lang yung distinct numbers, pero bawat isang absisa, meron siya naka-assign na weight.
Thank you po,
Okay?
sir.
All right. And then I hope you now have an idea how to derive, halimbawa, 6-point Gauss-Legendre quadrature rule yung ipapagawa ko. So, kunin nyo lang yung code nyo para sa Legendre polynomial, ipakompute kay MATLAB ano yung roots nun, Tapos, i-plug in yung roots na makukuha nyo dun sa formula natin para kay W sub i's, and then you're good. Or you could also use the derivation na ginawa natin last time. Magsasolve ka nga lang ng gano'ng kalaki yung system. Kung 6 points, meron kang 12 by 12 non-linear system. And that's not a good problem to have, right? Napakalaki na nung system. So mukhang mas efficient itong paggamit ng Legendre polynomials. All right? So yeah, at least nga nagsasalita na kayo. I really appreciate your questions. Some other questions or points that you want to raise? Kasi tapos na actually yung discussion. So tapos na yung module 9. So 2 modules to go. Tama? Hanggang module 11 nga lang ba tayo? Yeah, I think so. Hanggang dalawang module na lang yung natitira. Wala nang questions? Sure? Sige, probably I can give some hints on Lab Exer 5.2. Okay. Ang bait nung gumawa ng 5.2 kasi hindi na kayo pinag-derive ng bagong, hindi pala, pinag-derive kayo pero alam nyo na dapat ano yung kakalabasan. Kasi alam na natin yung quadrature, abscissas, at saka weights para sa 5-point Gaussian quadrature. So sa problem number 1, kailangan nyo daw i-verify yung nasa row, yung abscissas at weights para sa 5-point Gaussian quadrature rule. Kaya lang, hindi nyo pwedeng gamitin sa part 1 yung paggamit ng Legendre polynomials. Kasi kailangan nyo daw gayahin yung same strategy na ginamit para dun sa pag-derive ng 2-point Gaussian quadrature formula. So, ang kailangan nyo gawin, balikan nyo na, okay, 5-point Gaussian formula, so 5 points. Dahil 5 points yung gusto mong i-derive, magkakaroon tayo ng 10 unknowns. At yung mga abscissas at saka yung mga weights para sa kanila. Alright, 10 yung unknowns. So we'll have a 10 by 10 system. Alright, so 10 by 10 system siya. Ano yung mga equations? Yung mga equations manggagaling sa degree of precision. Ang degree of precision ay 2n minus 1. And that's 2 times 5 minus 1. So we'll have 9, degree of precision 9. So ibig sabihin dapat yung integral from -1 to 1 ni f of x dx ay equals sa actual quadrature value or actual value na makukuha natin dun sa quadrature, wi f of x sub I going from 1 to 5. So ito yung itsura nung equation na gusto nyong isolve where f will take the following function. Pwede siya, palitan nyo si f ng 1, palitan nyo siya ng x, palitan nyo siya ng x squared, hanggang x to the power 9. Kasi x to the power 9 nga, kasi degree of precision 9. So dapat eksakto yung integral na nakukuha natin para sa lahat ng polynomials of degree 9 or less. Tapos 10 ito, 10 yung integral na i-evaluate nyo. Alright? So, bawat isa sa kanila magbibigay sa inyo ng isang equation. Tapos doon yung mabubuo yung 10 by 10 na system. So, in the exercise, you're expected to show ano yung 10 by 10 na system. Okay? Pero hindi nyo naman kailangang isulat yung lahat ng detalye. Halimbawa, meron kang integral ng x to the, or alam na natin ang integral ng isang odd power dx ay equal kay 0. So, ang kailangan nyo na lang i-solve by hand yung integral ni 1 dx from -1 to 1, integral ni x squared, integral ni x to the 4th, x to the 6 hanggang x to the 8. So, makukuha nyo yung mga natitirang equation. So, isulat nyo lang yung system of equation. Okay? Tapos, pwede nyo sabihin using a solver, halimbawa, online solver, or using MATLAB. Ito yung mga solutions na nakuha nyo. So, we get x sub 1 equals this guy, x sub 2 equals this guy, hanggang x sub 5. Tapos w1 equals blank until w sub 5. So hindi nyo pwedeng hindi nyo na ipakita yung pagsosolve. Kasi hindi ko naman i-expect na isolve nyo by hand yung 10 by 10 system. So pwede nyo sabihin, gumamit ako po ng online solver, ito po yung binigay niya. And that's fine. Ang crucial dito ay makita namin yung equation. At makita namin yung process na, or maipaliwanag yun ng tama kung paano yung process. Okay? And the values that you will get here should be the same as the ones appearing in the last row of table 9.1. Okay? And then yung problem number 2, kailangan nyo lang gamitin yung 5-point Gaussian or Gauss-Legendre polynomial para i-estimate itong integral na ito. But again, you need to be careful because the abscissas that we get from number 1 would be on the interval -1 to 1. Pero this time, ang interval natin ay 0 to 1. So, ang mga function values na gagamitin nyo dun sa quadrature rule, ang ipa-plug in nyo ay yung translation ng mga exabytes na nasa table 9.1. So instead of simply plugging them for x, kailangan nyo muna siyang i-translate via the formula b minus a over 2 times t plus a plus b over 2 bago nyo siya i-plug in sa e to the x squared to get the function values that you should multiply with the computed weights, tas kukunin nyo yung summation. Okay? So I think that's it. And if you can do that, then you'll get a perfect score for exercise 5.2. Okay? So is that good? At least I hope I have given you some idea on how to answer 5.2. Though mukhang straightforward naman siya. Unless you have some clarifications or questions. All right, so if there are none, then good luck sa Exer 5.2 on Monday. Oh, by the way, holiday nga ba ng November 30? Tama, no? Holiday ng November 30. So we will not meet live, pero I want to still keep the synchrony between the two lectures that I am handling. So what I'll do is I would request you to either attend the section B meeting on Wednesday. That's medyo maaga nga lang, 8:30 to 9:30 sa Wednesday instead of our class on Tuesday. Or if you cannot make it then, you can just watch the recording for that session para yung second half na ng module 10 yung i-discuss ko on Thursday next week when we meet again. Okay? Okay lang ba yun?
Yes po, sir.
Okay lang po, sir.
Okay.
Okay lang din
All
po,
right.
sir.
Oh, good. Thank you, guys. So, pero relax muna kayo ng holiday, November 30th. Tapos balik tayo ng either December 1, join us live, or yeah, just watch the recording. Okay? So, that being said, so enjoy the weekend, guys. So, next week na tayo magkikita-kita. And until then, keep safe. And yeah, bye, guys. Nawalan ako ng sasabihin doon. Okay. Bye, everyone.
Thank you po, sir.
Bye po, sir.
Thank you
Salamat
po.